In today's lecture, we'll be studying different types of recorders, and we'll be starting with the ultraviolet recorders. So, ultraviolet recorder, as far as the ultraviolet recorder goes, it's an oscillographic recorder, and the construction of this recorder is somewhat like this. So this here represents our ultraviolet recorder. So there are a number of components of this UV recorder. The main principle of this UV recorder is actually the focusing of UV lights onto a paper so that a trace can be generated. The components of this recorder include a UV light source, a galvanometer coil, a number of galvanometer coils rather. You have a permanent magnet or a simple magnetic block. There will only be one magnet. You have the UV sensitive paper, and the galvanometer mirrors. The operation of this of this UV recorder, it's fairly simple operation. What we do is we simply pass the current through the galvanometer coils. The current is an alternating current, so accordingly that means actually a current carrying conductor is being placed in the magnetic field generated by the permanent magnets. So what will happen is that the galvanometer coils will start moving. So as the galvanometer coils start moving, the mirror will also move along with it, and the galvanometer mirror focuses the light on the UV paper. So what happens is once the mirror deflects proportional to the galvanometer rotation, that actually is proportional to the current flowing through it, we can see the trace of UV lights onto the UV sensitive paper being generated. So a proportional current flowing through a galvanometer causes current flowing through the galvanometer coil causes a proportional deflection of the galvanometer mirrors that will cause the deflection of the UV light source onto the paper to change. So using this device we can therefore measure or plot the trace of an alternating current flowing through the galvanometer coils. It's also we also need to note here that the paper The UV paper moves at different speed levels, and as many as 12 different speed levels are chosen for the paper to move. So in ultraviolet recorders we can actually choose between 12 different speed levels for the paper to rotate, and the paper dry mechanism will be responsible for that. Apart from that, we also need to note that the paper actually gives us different graphs. There are other traces available on the paper. We can see there are grid lines, there are timing lines, there is the recorded trace, Now, what are the applications of this UV recorder? Using UV recorders, we can actually measure both DC as well as AC signals. And as far as the AC signals go, we can measure any AC current waveform ranging between 400 to 500 Hertz. Next, what we are going to be studying today is the magnetic tape recorder. So, where does a magnetic tape recorder, where we preferably use a magnetic tape recorder? We have certain situations wherein we need the recorded information to be retrieved back, and we want to retrieve it back in the same form as the original source of the signal. It can be we actually want to retrieve it in the form of an electrical signal, and magnetic tape recorders help us retrieve the information back in the form of electrical current or electrical source of energy. Yes, and also using a magnetic tape recorder we can measure signals of higher frequency. So what are the different components of a magnetic tape recorder? There are 5 important components of any magnetic recorder. We have, first of all, the recording head, and the recording head looks something like this. So a recording head is more or less like a transformer. So you actually have a wire wound in the form of a solenoid, and the tape is exposed to the we have a wire that's found in the form of solenoid. We pass through the current. We pass current through this solenoid, so it will produce a magnetic field, or what we can say here, it will produce a specific type of magnetic path, a magnetic pattern rather, and the tape is exposed to this magnetic pattern. The tape will actually record the magnetic patterns that can later be used to produce back the electrical and the original source of energy, that in this case is the current. So using that magnetic pattern we can regenerate the current, and this is basically this information is basically recorded on the trailing edge side. So in short, a recording head is something that works like a transformer, that works as a source of magnetic field. Second most important component of a magnet tape recorder is the magnetic tape itself. So a magnetic tape is nothing but a coating of iron oxide on a plastic base. It is the iron oxide that actually is exposed to the magnetic patterns, and the magnetic patterns actually magnetize the iron oxide. The magnetic patterns basically magnetize the iron oxide on the tape, and this magnetization is actually recorded on the tape. We actually record the magnetic patterns on the tape. The third important component is the reproducing head. We understand the reproducing head basically retrieves back the information from the tape, and this information is retrieved in the form of current. It is the recording current. The current flows through the recording head, generates a magnetic pattern, is exposed to the iron oxide film. The iron oxide, when exposed to the magnetic pattern, stores information in the same manner, and the reproducing head regenerates current from the magnetic patterns, and that way we can actually retrieve the information back in the form of electrical signal. So reproducing head helps us retrieve back the information whenever necessary. The fourth important component is the tape transport mechanism. In case of a magnetic tape recorder, the tape transport mechanism looks something like this. This is the tape transfer mechanism. You might have seen a VCR So there are two sets of reels, the supply side and the take-up reel. There will be rollers that actually help the film or the tape to move. So the tape transfer mechanism will allow constant speed, will allow the tape to be will allow this tape to move at a constant speed without the reel to move at a constant speed. The recording head will expose the magnetic tape to magnetic field, causing this information to be stored in the form of a magnetic pattern, and that information can now be reproduced from the reproducing head in the form of an electrical signal. So the tape transfer mechanism, besides allowing the reel to move over the surface, should also make sure that the reel does not wear and tear, there is no loss of information, and there is a smooth transition of this reel over the rollers. Last but not the least, we have the conditioning devices. So we might need to amplify the signal, we might need to filter the signal to remove the noise extra. So conditioning devices are also included with the magnetic tape recorder. So in short, this is the mechanism, this is the principle of the magnetic tape recorder. And we also have the digital recorders, and digital recorders are of two types. One is the synchronous recorder and another one is the incremental recorder. What the synchronous recorder does is that in such a case, the recording will be done in a fashion such that the movement of the tape will actually move in such a fashion at a constant speed while recording, but as soon as we approach the end of the recording, there will be a change in speed and it will come to a sudden halt as well. There might initially be an increase in speed and then halt. While as incremental type of recording basically allows us to program the system so as to record the digital signal in a step ahead manner. We understand that in the digital tape recording that the recording will be taking place in the form of digital signals, that is in the form of binary numbers, mostly 0 and 1. So there are actually two forms of recording available in digital signals. One is the RZ, that is the return to 0, and another one is RNZ, NRZ. So in return to 0, we actually use only two logic signals. One will be 1 and another one will be 0. So we can actually use 0 and 1 to record any form of signal. While as in case of not return to 0, that's NRZ, what we do is we can record the information in the form of -1 and +1. You have studied already signed notations in case of digital circuits, and you understand that how we can represent a -1 and a +1 in digital form. So this information can be recorded and stored in our systems. Now, as far as the digital recorders go, they are fairly simple. There is not much effort in this. We have to simply store the logic 0 and the logic 1. So what digital recorders offer is this similar types of advantage as the digital systems basically offer. You will have higher accuracy, you will have lower noise, the system will be insensitive to tape speed, and we require simple conditioning devices. But there are some disadvantages associated with the digital recorders. The main disadvantage is the loss of signal, or what we can say is the dropout error. We can have basically extra pulses, or we can have missing pulses in the circuit. And because of which the recorded information will be different from what will be the retrieved information. In the next session, in the next 1 or 2 sessions, we'll try to conclude the syllabus.